Right, so hi, I'm Paul Durrant, Senior Principal Software Engineer at Citrix, working on XenServer. So I'd just like to have a quick talk about what we've done regarding the new DMOP hypercall and libxendevicemodel. So yeah, quick agenda. So we go back through the motivation for the hypercall, implementation then, and then what's kind of left to do in future. So motivation first. Restricting QEMU privilege. So this is something we've done in XenServer for a long time in a kind of a slightly hacky way, but it's a good idea because QEMU itself, as a device emulator, presents a very large attack surface. Device models can be complex things, subject to attacks such as buffer overruns, etc. QEMU is also, certainly in the XenServer use case, it's running in the control domain, has the same privileges as the tool stack itself, is usually running as root. Now we do deprivilege in XenServer, but in other deployments it's quite common to run QEMU as root because it needs to do things that only root can do. So options for a restriction. We could use subdomains. We don't do this in XenServer because it essentially presents a scalability issue. Now when you're running QEMU in the DOM0 control domain, at least the text segment of QEMU can be shared. Whereas if you're running a stub domain, then the whole memory image essentially of the emulator has to be completely duplicated once per each guest. We could use XSM. Problem is that XSM can only distinguish by DOM ID. And obviously if all your QEMUs are running in the same domain, then you have no ability to distinguish between them as far as XSM goes, so we'd need some sort of extension in that case. The current built-in policy for XSM is currently not proven. I don't think anybody really uses it, so it would take some auditing. And the other thing is that XSM has no ability to essentially introspect on what's being passed into the hypercall. It only has the ability to audit the hypercall number itself, essentially. So this is the implementation. So there's a various layers to this implementation. So the first part of it is in Xen. So we introduce a new DMOP hypercall with the intention that this is suitable for all device model operations. Important things about the hypercall are the target domain ID, i.e. the domain for which the emulator is running, is a first-class argument to the hypercall itself, and then all the other arguments to the hypercall are passed in buffer structures. And a buffer structure is essentially just a straightforward base and limit. So the guest handle in this case, the H is in the emulating domain, it's guest. And the size is the size of the buffer. By convention, the control for an individual DMOP is passed in the 0th buffer of the array, and then any subsequent memory handles that have to be passed are passed in subsequent buffer structures. So there was various patches that I put upstream where we converted all the existing tools-only HVMOPs, and those are HVMOPs that were only ever issued by the tools domain. There are other HVMOPs that were, that it's legitimate for a guest to issue. Obviously, they remain as HVMOPs because that's the right thing for them to be, and also for compatibility reasons. The tools-only ones have now been converted into DMOPs. Second layer is the priv command driver in Linux. I only had time to do Linux, other OSs will need to follow potentially to make use of this. But in Linux now, the priv command driver takes a new ioctl. You can see that the DMOP ioctl structure there is essentially analogous to the hypercall structure itself, in that it takes domain and then a number of buffers. And then the buffer structure again is base and limit. But these are user space buffers now, and the important thing is because they're it's a well-defined structure, it's easy for priv commands to audit these buffers using access OK. New ioctl has been added. This allows the emulator to voluntarily restrict itself to a particular domain. So when this ioctl is made, it means that priv command knows that every subsequent DMOP that's issued by the device model process should only ever be targeting the particular domain for which it's restricted itself. So therefore, if it is then compromised, at least its ability to further compromise is restricted only to the guest that it's restricted itself for. And the important thing is that once that hypercall is issued to priv command, it disables the standard freeform IOCTL priv command hypercall, which is the ability for user space to pass unaudited hypercall structures or unauditable hypercall structures into priv command. Next layer is the libxendevicemodel. So this is the abstraction layer in user space where the emulator is running that allows it to make DMOps. So it's supposed to be a stable API, so it's a new library. There's a compat layer for the old XCHVM function, so existing emulators that are compiled against just the standard libxen control will continue to function with no problem. And essentially there is an analogous libxendevicemodel call for all the relevant XCHVM calls. And then the one thing that the new library allows is for the addition of the xendevicemodel restrict function, which is the thing that makes that IOCTL to voluntarily restrict. Next layer, QEMU. QEMU itself. Now, this is upstream. QEMU takes a new xendomid restrict argument on the command line. It has been modified to use libxendevicemodel, so that involves essentially undefining a flag which removes the compat layer from libxen control, and then it now uses the xendevicemodel calls directly. It voluntarily restricts itself right at the beginning of HVM init, so there's essentially nothing happens before it's restricted itself, so it's already essentially restricted its attack surface by the time the guest gets hold of it. But there was one other thing, which is obviously QEMU needs to map domain memory to essentially emulate things like DMA. So we had to add something for that. So there is also a new call in libxenforemmem called xenforememory restrict. It's analogous to xendevicemodel restrict. Once that is called, priv command restricts mmap and mmap batch, v1 or v2, IOCTLs to the nominated target domain that's now linked to the file handle. Xenforememory restrict is also called right at the beginning of XenHVM init, right next to xendevicemodel restrict, and so it locks down that particular part of the API as well. So future work. libxl currently does not make or does not pass the xendomid restrict argument to QEMU. Problem with doing this at the moment is I don't think it's quite ready. There needs to be a separation essentially of the role of QEMU as a device model emulator and the role of QEMU as a PV backend. Now, if you use something like the QDisk backend, it is actually the same process, the same QEMU process that's doing the PV backend and the HVM backend. If we separate this and spawn a new PV instance of QEMU per guest that requires it, then we can stop calling BE register common in XenHVM init, which means that we no longer need to remove, we no longer need XenStore at all in that emulating domain. There is one caveat to that, which is that XenStore is currently used for passing the FISMAP information from the guest on migrate. That, I believe, patches were posted today or yesterday to actually remove that one, so we can actually properly stop talking to XenStore as well. Okay, one more thing. Yeah, QEMU already supports -runas and -chroot options. The chroot option is not used at the moment by libxl, and the -runas option is currently a bit awkward in the fact that we can't easily nominate a user for QEMU to run as because the username unfortunately contains the DOM ID name or the DOM ID number. So you have to know a priori what that DOM ID is before you can create the user to run QEMU as, so that's kind of slightly awkward. Another thing we could do potentially in QEMU to lock it down even more is consider using setrlimit to limit address space and file size resources. I believe in XenStore we already limit file size to make sure that QEMU can't essentially just write all of DOM0's file space and run it out of disk. In Xen, one of the things that I think has come up a few times in various contexts is that the magic pages are a bit of an issue. Currently, the way that QEMU gets hold of the pages from Xen is it actually maps them from the guest's space. So these are the pages that are used to pass the IREC control structures through to QEMU to handle emulations. So they're currently present in the guest's P2M, which means that they're actually mappable by the guest. So that potentially presents a bit of an attack surface. We have some security provided by the XenDeviceModel IREC server state in the fact that once that call is made, the pages are removed from the VM's P2M, therefore they're no longer mappable. And the idea is that when emulation is actioned, the guest can't map at that point. So whilst the guest can map them in certain cases, it can't essentially do any damage to a running emulator. However, there are problems with migrate where those guests have to be inserted back into the P2M so it could be migrated to the far side and then removed again. It's a bit awkward. It's not a great way of doing it. So there have been sort of proposals of a new mapping interface. The idea would be that you don't have the pages present in the guest ever. They sit in a separate map space that's not part of the guest. The guest can't see them, but the emulator can still get hold of them and they are still accounted to the guest. And I think Andrew Cooper is going to talk about this in one of the design sessions as well. Okay, I think that's it for my slides. I'm well ahead of time, so questions? It's on the end of the table. Yeah.
So just a small point. You mentioned this QEMU run as option and maybe the need to create a user. Yeah. So one of the things that we thought of some months ago was if you could reserve a UID range, you can add the DOM ID. If you have a 32-bit UID and the DOM IDs are 16 bits, so there's plenty of space there. You don't have to create a password file entry for it. You can just run it as a computed UID. That seems like a good solution. I have some like unreleased libxl patch series that does that. I don't think we want that in QEMU, but you could do that in the tool stack.
So you talk about libxl dynamically creating a user
It would not create the user. It would go -run as and just give the UID. And there would not be a password file entry for it.
Oh, I see. Okay, right.
Because you don't need a password file entry. And if you create if the starting username has a nice round number, then in PS and so forth, you'll be able to see the DOM ID in the UID when you see it in top or whatever. So
that
would be relatively
nice.
good to administer.
Yeah, that sounds a good idea.
Any other questions?
Any more?
No one.
Stony silence. Okay, I guess we're done then. Thanks.